All right, algebra students. So today we are going to be working with simplifying and dividing radical expressions. So last time we looked at multiplying radical expressions, and we saw that we could combine our multiplication into a single radical. This time we can do the same thing, but with division. So if we have two separate radicals, we can divide them under one radical sign. We will be using this concept for our first examples. Let's take a look at our first problem. We've got the square root of 36 over 25. So we can do this in one of two ways. We could, if we wanted to, split our radical, or we could try to simplify underneath. Because 36 doesn't divide by 25, let's split it instead. So we can write this as two separate radicals. Okay, so the big square root can go to both the top and the bottom. Well, we know 36 is a perfect square. The square root of 36 is 6, and so is 25. The square root of 25 is 5. Remember, the first page of your packet has perfect squares. So if you need a little refresher or reminder, you do have that resource just inside the front cover. So let's take a look at our second problem. Now, our second problem is very similar to the first one, so go ahead and give it a try on your own. Pause the video and then check back in. Okay, so on this one, I split my radical again, just like on the first problem, and then I simplified both. Okay, the square root of 16 is 4, and the square root of 9 is 3. Our third problem is very similar. We're going to approach it the same way. So we can split our numerator and denominator, and then simplify each. On this one, the only trick is that sometimes people forget that the square root of 1 is 1. As long as you remember that, you're all set. So our next problem is just like problem 3, so go ahead and try this one on your own. Pause the video, do the problem, and check back in. So here, just like problem 3, I split my radical into two separate radicals, and then I simplified each. Okay, so let's go ahead and try number 5. This time, we don't necessarily want to split our radical right away because 12 and 75 are not perfect squares. However, we can reduce these. So underneath the radical sign, we can divide both 12 and 75 by 3. So we can simplify that fraction. So we're going to keep our radical sign as a big radical sign. But we're going to do 12 divided by 3, which is 4 in the numerator, and 75 divided by 3, which is 25 in the denominator. Now it's just like the problems that we've already done, where we can split our radical. And from there, simplify each. Okay, so problem 6 is very similar to problem 5, where 18 and 32 are not perfect squares, so we don't want to split the radical right away. So go ahead and see how you can reduce the fraction underneath the big radical sign first, and then simplify. So please pause the video, try the problem out, and then unpause to see how you did. So on this one, 18 and 32 share a common factor of 2. So we can divide both the top and the bottom of the inner fraction by 2 to get 9/16. They're still under the radical at that point. And so then from here, we can split our radical to the square root of 9 over the square root of 16, and then reduce both of those by taking square roots. Okay, now we're going to be doing what's called rationalizing of radicals. And so this sign might look familiar to you because we have had it up on the board all year long, where we have a radical in a denominator and a big line through it. Okay, and so that when I say no radicals in denominators or you need to rationalize, what I mean is fix this. Okay, so the way that we do that is we can take the radical from the denominator, and if we multiply the square root of 3 times the square root of 3, we have the square root of 3 squared. And remember that squaring and square rooting will cancel each other out, so we just end up with 3, so we can get rid of our radical. So that's the idea behind what we're doing right here. Because we can't just multiply the denominator by something, that would change the value, we have to multiply by the square root of 3 over itself. And we chose that because that's the radical from the denominator. Okay, so we'll practice this concept in the next examples. If we take a look at problem 7, we've got a radical in the denominator, root 2. So to rationalize this, we can multiply the denominator by root 2, but to make sure that we're not changing the value, we need to multiply by something over itself, so root 2 over root 2. So then what we'll end up with, remember when you multiply fractions, you multiply across the numerator and across the denominator. It's different than adding. So in the numerator here, we're going to get 3 root 2. And in the denominator, we're going to get root 2 times root 2. So let's just do that as a little thought bubble. Remember that that's going to be the square root of 2 squared, which will equal 2. So multiplying a radical times itself gets rid of the radical sign, but you keep what was underneath. So multiplying root 2 times root 2, if we use this, we'll have just 2. Now be careful, because we can't reduce these 2's. Root 2 is different than 2. If we take our calculator and we try to come up with what root 2 is, kind of hard to see with the glare, the square root of 2 is approximately 1.41 going on and on and on. So we can't say that divided by 2 equals 1. So we're just going to keep our root 2 in our answer, and we're done. We would be able to simplify the outsides if those reduced, but they don't. So let's take a look at our next example, and I'm going to go through this one with you. You can do the beginning part on your own if you want to pause, test it out. Let's go ahead and do that. So do your first step, figure out what you want to rationalize by, and do that multiplication. Make sure to pause the video now. Okay, so on this one, we should have multiplied by root 6 over root 6. And then remember, root 6 times root 6 is going to be 6. Multiplying across the top, 8 times root 6 is 8 root 6. Now the reason on this one that I said just do the first step is because I knew that this one was going to be one where we have to reduce. So if we look at 8 over 6, we can reduce that part of the fraction. We still can't touch what's inside the radical, but we can reduce those. So 8 and 6 share a common factor of 2, so we can divide both of those by 2. And that's where we'll end up with our final answer. 8 divided by 2 is 4. Keep the root 6 that's in the top. And then 6 divided by 2 is 3. Remember, we can't reduce from underneath the radical, just from outside. So if we look at problem 9, this time we have a radical in both places. That's okay. We're allowed to keep radicals in the numerators. We just can't keep a radical in the denominator. So we're going to start this one the same way. We're going to take the radical just from the denominator and multiply by that over itself. So in this case, we're going to multiply by root 7 over root 7. So just like before, we're going to multiply across the top and across the bottom. So remember from yesterday or from the last lesson that when you multiply your radicals, you can combine them as a single radical. So we don't have to keep root 5 and root 7 separate. We can write that as radical 5 times 7. Now in the denominator, hopefully we can move past having to write this out. Root 7 times root 7 should just be 7. Then from here, we can multiply underneath. And we can say that we have the square root of 35, because that's 5 times 7, over 7. Okay? Now on each of these, again, we're always looking, can we simplify further? We didn't have to worry about reducing because 2 is prime. 6, I know, is 3 times 2. Both of those are prime, so we can't simplify that radical. And 35, I know I don't have to simplify because 5 and 7 are both primes. And so 35 is a product of primes, so I know I'm done at this point. You can always check back with how you got to there if you need to. Now, problem 10 is very similar to problem 9, but it looks a little bit different. This time, our radical is over both, just like the first problems that we did today. Well, there we split it to do, a perfect square divided by a perfect square, or we might have reduced one or the other and then dealt with our perfect squares. Well, these don't reduce and neither are perfect squares. So instead, what we can do is we can split them to write this as the square root of 3 over the square root of 7. Now, it's very similar to problem 9. So at this point, now that we've split it, pause the video, use problem 9 to help you do this problem, and check back in to see how you did. So this time, to rationalize, I multiplied by the square root of 7 over the square root of 7, because that's the radical that's in the denominator. And then I remember that I can multiply my two separate radicals under one square root sign. And then root 7 times root 7 is 7. 3 times 7 is 21. I know that's not going to reduce because both 3 and 7 are primes, so I left it here. So now you can see that writing your radical signs carefully makes a big difference, because here the square root should just be in the numerator. Here the square root is over everything, and sometimes people tend to, make theirs a little bit shorter or not cover everything, and that would actually change the problem, because the square root of 3 by itself over 7 without a radical, you wouldn't have to reduce. You would be done at that point, where this one is a different answer altogether. So when we take a look at problem 11, it's very similar to what we've been working with. We can do kind of the same thing to start that we did on number 10. We can split into the square root of 5 over the square root of 8. Now there are a couple of different things we can do at this point, because root 8 can be simplified on its own, so we could simplify that. So let's try that out. I might have you do this two ways. I haven't decided yet. So let's first simplify root 8. So I'm just off to the side going to do one of my little factor trees, just looking at the square root of 8. And I know that's 2 times 4 and 2 times 2. So I have one pair and one not. So the square root of 8 is the same thing. The square root of 8 is going to be the same thing as 2 times the square root of 2. Okay? So what I'm going to do here is I'm going to rewrite with the square root of 5 on top, and then instead of root 8, I'm going to write 2 root 2 on the bottom. So the reason that I did that is because on each of these we've only had one radical in the denominator. Well, on this one, we still just have this radical. We happen to have a 2 there. We don't need to multiply by everything. We just need to multiply by the radical. So to rationalize this, I'm going to multiply by root 2 over root 2, just the radical part. So in the numerator, I'm going to multiply 5 times 2 under 1 radical. In the denominator, I'm going to multiply across. I'm going to keep this 2. Then my root 2 times root 2, remember, is 2. So I have to remember that too. Lots of 2's. So then from here, we can simplify. Inside the upper radical, we've got the square root of 10. And down below, we have the 2 that had been outside, and we have this 2. Multiply together to get 4. Now 10, remember, is a product of primes, so we can't simplify that radical, so we're done at this point. Okay, so our alternate approach would be up here, what if we had multiplied times the square root of 8 times the square root of 8 over the square root of 8? If we had done that, then we would end up with 5 times root 8 in the numerator, and I'm just going to jump ahead and call that square root of 40. And in the denominator, we would have had 8. Well, 40 has a perfect square in it. Remember that 40 is 4 times 10. So we can rewrite that. You can do your factor tree, or you can think of it like that, still over 8. And so then the 4 can come out, so then we can call this 2 root 10 over 8, which just happens to reduce into the square root of 10 over 4. So that's if we did it the alternate way. Okay, I think the way that we did it is a little bit more streamlined. I think we would have to write a few more steps to really understand that one. Okay, so our last problem, we have the square root of 2/27. So let's try this the way that we did this first one. We're going to start by splitting the square root of 2 over the square root of 27. But then 27 we can simplify. So you can try to do a factor tree if you want to. Or you can try to do it the way I did square root of 40. I can think of the square root of 27 as the square root of 9 times 3. And really what I did here when I did the square root of 4 times 10 is, remember, you can split this. The square root of 9 times 3 is the square root of 9 times the square root of 3. Well, the square root of 9 is 3, so we have 3 root 3. You would get the same thing if you had done a factor tree. So let's rewrite our denominator using our simple radical. So we have the square root of 2 from the numerator over 3 root 3 in the denominator. Now when we go to rationalize this, we need to multiply just by root 3. We don't need the rest of it over itself. So multiplying across the top, I'm going to be wild and crazy. We're multiplying 2 and 3 under the same radical. We're going to get root 6. Okay? In the denominator, we're going to keep the outside 3, and then the root 3 times root 3 also turns into 3. Okay, where now we can multiply 3's in the denominator. Remember, root 6 doesn't reduce because it's just 2 times 3, so we can't pull any perfect squares out. And we have all of this over 9.